Honors Math 2, Unit 8. In Unit 8, we talked a lot about the unit circle. And so when we covered this way back then, I was really hard on you about making sure you knew how to do all of this without a calculator. And so now that we're going into a final, and since your final has calculators available to you, I'm going to tell you the way that I'm going to be posing questions on the final will be in a way that it's going to be really hard to use a calculator to get you out of it, if you know what I mean. So you have to still know how the unit circle is used, how it is set up, and don't expect the easy questions like if I saw number 23 and you could simply plug that into a calculator if you have it in degree mode and it'll tell you what it is. If I plugged in tangent of 225 on a calc, I know if it's in degree mode, my calculator will give me the ratio. So let's go ahead and start, and let's just review some things, and we're going to go from there. Here's the quadrant 1 version of the unit circle. You may or may have forgotten that we measure the 5 major angles that we use all the time. They are measured in degrees and they're measured in radians. So 0 degrees starts there. Then we go to the 30 degree mark. Then we go 45 degrees. Then we go 60 degrees. And then we go 90 degrees straight up and down. That's what it is in degrees. We could technically go all the way around the circle based off of those increments. Then we also did it in radians. 0 radians, pi over 6 radians, pi over 4 radians, pi over 3 radians, and pi over 2 radians. I'm hoping that that rings a bell for you. And then if we were to think about the coordinates, the x-coordinate, which is your cosine, the y-coordinate, the x-coordinate, and then the y-coordinate, which is your sine. There's a pattern to it. We're going 1 to the right, we're going 0 up. And the pattern goes like root 4 over 2, root 3 over 2, root 2 over 2, root 1 over 2 reduces, and then root 0 over 2 reduces. 1, root 3 over 2, root 2 over 2, 1 over 2, and 0. Same thing happens the other way around. It goes 1, root 3 over 2, root 2 over 2, and 1 over 2, and then 0. If my memory serves me correct, that's how we filled in the unit circle. And what we learned way back in the when was that we could figure out any trig ratio for sine and cosine if we knew that the cosine dealt with your x and the sine dealt with your y. So if we were trying to figure out what the sine of 30 degrees was, we could go here to the sine of 30 and know that that was our y coordinate. The sine of 30 degrees was 1/2. And then I even taught you a hand trick that talked about 30 degrees. We folded the finger down. We talked about cosine being here, sine being here, and that the sine was root 1 over 2, which is the same thing as 1 over 2. Well, how do we figure out what tangent is? Tangent is the sine divided by cosine. So if I was doing the tangent of 45 degrees, it's the sine divided by cosine. And what I showed you way back in the when was it was this many fingers, the sine divided by the cosine, and 2 divided by 2 is 1. The hardest parts for us was to remember how to do these other 3 functions called the cousins. I called them the cousins because they were related to these guys, except a little bit different. Secant is the cousin to cosine. They are reciprocals of each other. So if I know that the cosine of, let's say, 30 degrees, the cosine of 30 is root 3 over 2. The secant will be the reciprocal of that, or 2 over root 3. We will rationalize that for you. 2 root 3 over 3. So all I have to do is remember that the ratio is a reciprocal for the two trig functions who are cousins to each other. Sine and cosecant are reciprocals of each other, and tangent and... Whoa, there's another typo. I keep finding typos as I am looking at this thing. This should not say secant. That should say tangent of theta. I'm sorry. It should say, thank you, cotangent of theta. Let's fix that right away. That's 2 typos already. That bugs me that I did not catch those last year. Catch them this year, though. Okay. Yes, sir.
What was the first typo?
I can't remember. It was on the other unit.
It's supposed to say H, but it's an E.
Yeah. It was just a numbering issue. Not a typo in the question, though. Okay. So you will have to fill out the chart based off of this, and you have to know that the reciprocal of tangent is cotangent. We'll go from there. How do we convert between degrees to radians or radians to degrees? We have to know the conversion factor. If you are going from degrees to radians, all I have to do is know what is equal to each other. I know how many. If I want to get rid of degrees, I put degrees on bottom, and I put radians on top. The thing that we used back then was that 180 degrees is the same thing as pi radians. So if I want to figure out what 210 degrees is, all we really have to do is multiply by pi over 180. 210 times pi over 180. 21 over 18 reduces, divide by 3. Divide by 3, 7 is 7 pi over 6 is what I'm getting, which makes sense because that's quadrant 3. If I want to convert between radians to degrees, and I want to get rid of radians, radians are on top, radians are on bottom, to get rid of them, and I want to switch to degrees, I'm going to multiply by 180 over pi. The pi's would reduce. 12 was going to be able to reduce into 180. Let me divide by 6. Divide by 6. Divide by 2. So if I know that negative 17 times 15 is negative 255 degrees, that's how I switch from radians to degrees. You just multiply by a conversion factor. How do we find coterminal angles? Coterminal angles are the same angles that end in the same spot. If they end in the same spot, then that means we just have to go and either add a revolution or subtract a revolution to it. 7 pi over 3, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3 is right here. If I want to, I'm going to subtract one revolution. I am subtracting 2 pi radians from that angle. If I subtract, let me just write that. I'm subtracting one revolution from 7 pi over 3. I convert it to have a common denominator. It's 6 pi over 3. I know that one of the positive coterminal angles is pi over 3. If I wanted to find a negative coterminal angle, I would subtract another 6 pi over 3 from there. These are 2 possible coterminal angles for that angle. Don't always add 6 pi over 3 over 3. It just depends what your denominator is. If there's a pi over 6, then you're going to need to add or subtract 12 pi over 6, because that's 2 pi. We always add either a full revolution or subtract the full revolution to get to our coterminal angles. And then come the problems. All these is the major idea. Being able to do a bunch of these quickly without a calculator was super important back when we were taking this test. I love asking the questions that are the cousins, just so you know, because those ones don't show up on your calculator. You can't find a cosecant button on these Casios. All we ever sine, cosine, and tangent. So I ask these because then you have to know radians, then you have to know degrees, and you have to know your unit circle to be able to answer them. The things I want to caution you or remind you about, if we talk about sine of 4 pi over 3, you have to know what quadrant you're in. 1 pi over 3, 2 pi over 3, 3 pi over 3. 4 pi over 3 is in quadrant 3. Is the sign negative or positive in quadrant 3? The sign is negative. The hardest part is checking the sign for which quadrant you're in. So I want to give you a reminder. The reminder is this. We learned way back in the when that it was the cosine was positive, the sine was positive in quadrant 1, that it went negative, positive, negative, negative, positive, negative, as far as cosine on the left, sine on the right. We also learned a little acronym. All students take calculus. All of them are positive here. Sine is positive here. Tangent is positive here. Cosine is positive in quadrant 4. Those are two different ways for you to remember what's negative and positive in which quadrant, because the angles change. Sometimes you're in quadrant 1. Sometimes you're in quadrant 3. Sometimes you're in quadrant 3. And so on. Once you know that you're in quadrant whatever, quadrant 3, now you know it's negative. Sine of 4 pi over 3 is root 3 over 2. How do I know that? Because I know my hand trick. The hand trick says go and find the pi over 3 angle, fold it down, count how many fingers you have for your sine, count how many fingers you have for your cosine. It's square root fingers divided by 2. Root 3 over 2. It's negative because it's in quadrant 3. If you forgot that, maybe you might want to go back to the video in Unit 8 on the hand trick. I think it was section 4 or section 5, if my memory serves me correct. What about a negative angle? Well, negative angles go the opposite direction. Instead of us starting and going counterclockwise, what if we go clockwise? 150 degrees, about this much. 150 degrees. That would leave a 30-degree angle left over. That's your reference angle. But the first thing you check is cotangent negative or positive in quadrant 3? Cotangent. All students take. Tangent and cotangent are positive here. So I'm going to put a positive sign so I know it's positive. Doesn't matter what that angle is. The angle just tells you where you are. 150 degrees, we use the 30-degree reference angle. Cotangent, cosine divided by sine. Square root fingers divided by square root fingers. Which means number 24 is root 3. In all the problems that you have, knowing the unit circle, knowing the hand trick will get you out a lot of stuff. It'll even help you solve problems like 27, 28, and 29. 27 says, what's the cosine of 3 pi over 4 times the sine of 3 pi over 4? Well, where is 3 pi over 4? It's right here. If you don't know, 1 pi over 4, 2 pi over 4, 3 pi over 4. Cosine is negative. Sine is positive there. 3 pi over 4 means that I go to the cosine, square root 2 over 2. It's negative. Times the sine, which is positive, root 2 over 2, using the same ratio. Well, what is a negative times a positive is a negative. 2 times 2 is 4. Root 2 times root 2 comes out to 2. And that simplifies to negative 1/2. And I didn't even touch my calculator because I know my unit circle so well. You will need to review it, most of you, because we haven't done a lot of unit circle. But you're going to see how Unit 8 applies directly to Unit 9 when we get to the Unit 9 review as well. That's where I'm going to end this review.